Hey everyone, welcome to the stream. I just saw that before I even started, Cog Whistle is following me. Thank you very much, Cog Whistle. I appreciate that. All right. So, a couple nights ago, we wrapped up audio implementation. So sound is now working in Vectrexy, and we started working on trying to get Spike to render correctly. Now, since last stream, so just like basically yesterday, I also tried to get the Linux build of Vectrexy to play sound because it should work. And actually, I learned a couple things about Linux. So before we get onto Spike, I'm just going to talk a little bit about that and just kind of wrap up this this Linux stuff. So basically, the way I configured, like the way I recommend configuring Linux builds, or at least the way I build the Linux version so that I can distribute it, is by doing static library builds. So I use VC Package, and VC Package basically, at least on Linux right now, only makes static libs. Which is kind of good because it means that distribution is easier. But it turns out that the way I was setting it up, it's kind of interesting. So I made a build, a Linux build, and when I would run it on my Ubuntu here, it would not actually initialize sound correctly. Oh, hey Pyro, how's it going? So yeah, it was not actually initializing the audio device, and that was kind of weird because when I would actually build directly on my Ubuntu, it would work. It's like audio actually worked. But when I was getting the version that was being built by Travis, which is on some cloud machine that Travis runs, the version it would build would just not initialize the audio device. And so I started looking into that. Oh, I'm pretty good, Pyro. Thanks. So I started looking into that, and then I fell upon this README here on SDL and how to build it specifically for Linux, and it explains here how the build dependencies work, and that effectively, as it says here, it says by default SDL will only link against glibc. Then it says the rest of the features will be enabled dynamically at runtime depending on the available features on the target system, right? So that makes sense. So for example, if you built SDL with Xinerama support and the target system does not have Xinerama libraries installed, it will be disabled at runtime. And you won't get a missing library error, at least with the default configuration parameters. Now, the key here is saying that if you built SDL with this support, and so the way I was building SDL was with a very small set of libraries installed. In particular, when it comes to sound, I was only installing this one here, lib snd.io, so sound.io dev. But actually, here what they say. They say with Ubuntu 13.04, all available features enabled, you would have to install basically this large list of dependencies. Now, some in here are just for like being able to build, but the important ones come around here. And in there, I noticed libasound2, libpulse, libaudio, and then later on is libsound.io. And there's also libsample_rate here, which it explains here that libsample_rate, it says here, libsample_rate 0 dev lets SDL optionally link to libsample_rate at runtime for higher quality audio resampling. So that's interesting, right? So basically, what that means is if you really want to build a static version of SDL that is the most compatible, that has like the ability to take advantage of whatever libraries you have installed on different versions of Linux, you'd want to have all of this installed. And so I did that. I basically went into my Travis script here and I added this large list, which is basically from that README. And formerly I only really had this one here. And then the version that got built from Travis and deployed that's the one you can basically download from, like this is on my GitHub, on GitHub here at the very top. see you can download this version of Vectrexy for Linux. Now that's the one that gets deployed, and it's the one from Travis. So now that I did this, the version finally builds and runs correctly. So I can actually show that to you here. I'm going to stop my music. Yeah, so I downloaded it, I extracted it to this folder here, and then if I run Vectrexy, now the frame rate's not superb because I'm streaming, so we're at 40, but you can hear the audio there. So that's pretty cool, right? So I'm just glad that that all of that is working. I actually had added a whole bunch of debug output because I was trying to understand what was going on. And actually this helped me understand. So you see here, I list a number of audio devices that are detected, and I list the devices. And here you can see it detects some, I guess, yeah, Sound Blaster, PCI, whatever thing. I don't know, I guess this is some kind of emulation of the sound card I have, because this is a virtual VMware workstation, right? It's a VM. And anyways, now it opens successfully, but in former versions, what would happen, I think actually Vectrexy 9 has the problem. I mean, this is an earlier version. So you see, I get this assertion here about, this is deep from SDL audio detect devices default, and it says that only has default output device, and if I ignore, see, eventually it comes down to number of audio devices. So it actually says I have one called system audio output device. Oh yes, that's right, Pyro. Yeah, I did fix the audio. Like it sounds way better, right? And then so it says that it found one, but then when it tries to open it, it fails. And then I put in some code to try and open, because there's like open default, and then you can say open by device name. And then it ends up failing, and I actually, don't continue. In actuality, what I should be doing is allowing the emulator to just run without sound support, which is totally doable, and I added that to my list of things to do. But anyways, then after that, I was like, it's weird, it's weird that it shows this. And then what happened is with the same code, I built Vectrexy in this VM and ran it, and I saw that it was giving me a different output audio device. And then I started thinking, like why would a version built on a different, in a different VM like the one from Travis be any different from the one I built? And then I started looking into how to build Linux, SDL for Linux statically, and that's when I stumbled upon this this README that I was showing earlier, this one here. So that's basically the full story. So I added all this, and now we're in a good position. So I just kind of want to get this. So I updated this. I'm updating my README for Ubuntu just to say that, install some Linux specific libs we depend on, and I'm writing here that you can also install these SDL static lib dependencies, which is this large list now. And I think I'm going to say that alternatively, you don't need to do this. You can also just install, you can just apt-get SDL2, and I think you get everything you need. So the difference there is you can get, that's like the dynamic library. So if you just wanted to build Vectrexy and just run it locally and not distribute it, that would probably be the easiest thing to do. So there's different ways to go about it. So, and I think on Linux, most people go with a dynamic library. Most people build against dynamic libraries because that's what you get when you do the apt-get thing, right? So, if I do apt-get search, apt cache search, and SDL2. So yeah, you have a whole bunch of stuff here, and I think libsdldev2 is what we would want. I don't even know if I can copy from here. Yeah, I can't copy. Let me see here. Maybe I'll say install something that we depend on. I don't know. If you want to build SDL, you know what? I'm just going to do this. You can build. And I think I'm going to have to also say libstl dev2 libstl2 dev. To use something like that. I think Linux people will understand. I don't have to go into too much detail there. I mean, in that case, you wouldn't need to do SDL2 here, and probably you'd want to get libstl2 dev and libstl2-net dev, and then forget about these. So something like that. Okay, I'm just gonna get all this squashed down. So I'm just gonna say reset here, mixed. Let's see, what do we got here? Let's see. Yeah, see, this is what I used to have. Just libsound.io. Now I have all this. Okay, I'm going to remove that. I also went ahead and realized that by default on Linux, I was building a non-release version, and what CMake does there is it builds everything in debug, including like enabling assertions and stuff like that. So you have to explicitly tell it that you want to build a release type, and then you get like an optimized version without ndebug defined. So it's actually going to run faster, which will match what I do for for Windows when I build the version that you can download. All right, so there's that. Updated the README, okay. So I'll say add missing SDL2 static lib dependencies, fixes audio, and build release version. Okay. Oh, and actually I wanted that to be master. So I'll just force master here. Actually, no, you know what? It's okay. And then I wanted to see here. So yeah, so this is the code for that I added for sound initialization. I think I'm going to leave it here because I think it's useful to see this stuff. Opening default audio device. Something like this, trying explicit ones. Now, if we failed, what we want to do is we still want to be able to continue like the emulator should still work whether we are able to use sound or not. We just kind of want to make all of this a no-op. Now, that's kind of crappy. You know what? I'll do that another time. It's on my to-do list anyway. I think I added it here. Support disabled, no audio device. Okay. So let's see what this looks like. Okay, that's good. Say succeeded, failed. Opening default audio device, number of audio devices. It's interesting to note that the font color changes, and I know why that's happening. It's my debugger that does that. It's interesting. Anyway, okay, so let's commit this. STL audio driver, and I'll say attempt to open audio device explicitly if default one fails. I mean, I don't really think this is that useful, to be honest, because if the default one fails, we're probably, yeah, maybe I shouldn't bother with this. This was mostly because it wasn't working. Yeah, I'm not going to commit this. I'm going to just stash it. Oh, actually, I should name my stash because it's going to be very confusing. I'll say yeah, so in that case, yeah, sorry, this is not like exactly what I said I would work on, but I did want to get this fixed, so I'll just fast forward here. Whoops, that's not what I wanted. Okay. And I'm just going to push this. Yeah, so basically when I work on getting Travis to work, what I do is I make a branch like Fix Linux, and then I just do a whole bunch of submits, and I wait for Travis and see how it goes. And then when it's working, I just reset and do what I just did here. It works. Thankfully, it doesn't take too long for Travis to build Vectrexy. It's about like 10 minutes. All right. So Pyro, are you, I forget, are you on Linux or are you on Windows? Oh yeah, this was my attempts to see if I could fix it last time. Okay, so you have an Ubuntu 16. You know what? Maybe you could give it a try at some point. Just let me know if it actually works. This one that I pre-build. Because like I don't actually know if anyone's ever tried my Linux builds. You know, the ones that I provide on my GitHub page. I know people who've downloaded the 32-bit and the 64-bit Windows ones. Those ones are working. I mean, I've tested them, and now it works in my VM, so that's a good sign. Yeah, but if you ever get the chance there to just like give it a whirl, see if it actually works all right for you, I'd appreciate that. All right, so where are we at? We are trying to get Spike to work. And let me show what that means, what I mean by getting Spike to work. So here's Spike. Thanks, Pyro. Okay, so the problem is that you see these platforms here, there are supposed to be some of these that are missing. You know what? Try not updating it. Just curious to see if it actually works. Because I know that Travis uses like some older image of 1604 to try and be as compatible as possible, I think. But I don't know. Anyway, you can let me know if it works out or not. You don't have to spend too much time on it. Okay, so these platforms here, this isn't correct. And last time I did this, I ran Para JVE, which is an excellent Vectrex emulator. Let's see, run Spike. And we were doing this. And right there you can see the difference, right? So you see these here are not drawn, whereas for me they are. So yeah. And I don't know why. I also notice here my 4 is a little bit clipped. Fascinating. One of the things that was pointed out also last stream was that it looked like... that doesn't seem so... Yeah, you see how when we start here we don't have lines coming out here? It's a little bit odd. Or like here. And then what happens is that at one point, boop, this thing appeared here. So I mean, it looks like it's all related, and I don't really know why it's doing that. So one of the things that I wanted to try and do was try to kind of color or figure out a way to show the separate line segments that we're drawing. I think that would be maybe insightful to get that. I'm also wondering, because I was working on this branch here, and I'm wondering if it was useful. Okay, nothing major here, just minor changes. I'm going to ignore that. There was something that I was doing that was nice, which was Pious ROM. Oh yes, that's right. So in the data folder for Para, there are these system ROMs, and there's these fast boots and skip boot. I'm going to take the skip boot because it goes really much better. So now it should like jump right into the game like that. I'm just wondering if what happens when I step here. We can kind of see the beam moving. It's interesting. Let me see something. I wonder if it is using the BIOS, and if we can like put a breakpoint somewhere in the BIOS routines. Because what would be really cool would be to see like line by line being drawn, but I don't know if I can do that. That's pretty cool, and it looks a lot like a CRT. Yeah, it's true, right? It's so weird. That's like the first time I noticed that behavior. I don't know like when we're going to see it again. Oh, there it is. Huh. Fascinating. F1AA. I'm just paying attention here to the addresses because we know that when it goes to F1 into the Fs, it means that we're in the BIOS. So let's see what F1AA corresponds to. Yeah, so I did say that it had its own draw routines, and that's very possible, which is, you know, but I'm not sure about it, but it's a guess, an educated guess anyway. But we'll see. So what was I looking for? The BIOS, have like a listing or something? Why don't I have it? Oh, here it is. DP to D0. Okay, it's just one of those functions where you can copy values from one register to another. Here it is. So that's not super interesting. Reset pen. Reset the pen to origin. Let's try something. Let's put a breakpoint on that. That's interesting. So we're not seeing the lines persist because by kind of breaking and running, my rendering code gets like a 100 millisecond delta time, and then actually gets a big fade out. It would be kind of interesting to slow that down, and or even make it like, you know, if I could set in my debugger how much time the rendering gets, I could even set it to 0, and then we would see all the segments remain. Okay, so you see what's happening is that, and so this makes sense. So we've hit on this function. This function reset pen, it resets the pen to origin, and the way it works with the Vectrex is you basically want to always reset your pen to the origin, and then, you know, draw your next object, like move it to the next position and draw. Because if you try to draw one object and then go to the next relative position for the next object, first of all, it's difficult to code, right? Because you need to compute like differences in where you are to where you want to be, rather than like go to the center and then go to the absolute position of the next object. But also, from what I've read, over the frame time, the position of the beam will drift, and so you actually will get, like, you know, weird artifacts because things you draw later, you know, like there's an error that accumulates over time, and things will kind of look wobbly or strange. So it's very common to go back to the center. And I actually had a bug in my emulator that's easy to reproduce that shows the very fact that it keeps going to the center. But I don't really need to show it now. But basically, we can see that by putting a breakpoint on the reset pen, we can see how what's the object that gets drawn for each one of those. So the ladder gets drawn, then the key again, maybe this line at the top for that. See that? So that line actually is part of the problem, right? See this whole line here. It's surprising that it would draw a whole line in between. And yeah, so like what it should be doing is, you know, drawing and then not drawing and then drawing like for the parts that are supposed to be turned off. Here again, we get the full line segment, and then we start getting, you know, these bits here. And I think all those lines will always be drawn, right? Like basically, if we pay attention, at most you have one gap in between platforms, never more than one. And so that means that it can always draw these lines. It's really just about the connecting lines between the platforms for where there's a gap that should not be drawn. Okay, so let me do something here. Okay. So this is my startup script for my debugger. I'm just wanted to put a breakpoint so I don't forget. So what we could do now is actually, I wonder if we could try to understand this render here from F35B to F35B. So if we do a T-N trace.text, let's just print, I'm going to guess that in the last 100,000 instructions, we'll take a look. F35B. So there's one. Okay, so that's the bottom one here. Where are we here? F359. F359, and then we are at F35B. Okay, so this one here is the last time we hit it. So we can delete like all this above it. So this bit of code would be the line draw that currently is drawing too much. So I guess first thing, let me just see what other BIOS routines are being called, because we can see there are a few in here for sure. F35B, because let's see. F1AF, DP to C8. Yeah, that's true. Yeah, we'll do something like that. Just gonna try and get like because it's not too much code here, you know? So I'm just gonna try and get like a big picture. And obviously there's a lot of repetitious code in here. Pretty sure we're gonna find like a loop in here where it's doing segments. But you're right, that when there are writes to the DAC, that would be for setting the positions. Or rather, setting the velocities. That's not super interesting. Let me see. Clear X, clear XB. Just a bunch of repetitious code. Okay, so yeah, because we can see where we're starting to manipulate the via in here. Actually, yeah, it starts off pretty soon. So this does look a little bit like we're doing some. Okay, that's sent to 0, that's true. And then back in here, via T1 count low. And I have to refresh my mind a little bit, my memory a bit on how the rendering works, because it's been a long time I haven't actually looked at this code. There was a time when I was able to read this, actually remember the details, but it's been a while. Definitely a lot of via stuff here. Okay. So see if we search for port A, on the right side here we can see that there's like just a few hits. 1, 2, 3, 4, 5. So that might be the, say, number of segments. 1, 2, 3, 4, 5. 1, 2, 3, 4. So yeah, you know what? Let's put breakpoints. See if we can do this. That's true, Pyro. There could be, but for me, I was looking at the single line draw, right? This is the code for the single line draw. You know, now we don't, oh, actually we still see it. Not here, but I have to like minimize things. This here. This single line draw, that's ostensibly the code I'm looking at, right? So if that's the case, and you know, I suspected that it would be drawn in segments because it shouldn't be solid. It really should be like broken up, right, into parts. But for some reason it's solid, and there's a bug somewhere in my emulator where I'm not catching the state of when it should be turned off. And it's probably like a timing thing, and it wouldn't be too surprising. There is a little bit of an interplay between, you know, writing values to registers versus, you know, updating the via for the cycles. But honestly, it's like it's still, it would be kind of surprising, because basically when we write, that will cause, let's say, a write to port A to occur, and then we also update the via for the number of cycles that instruction would have taken. So any kind of like timing based thing should occur, you know, like if there's a set some value in a register and then do something with it, it should happen pretty much right away. Like what I always worry about is things like, you know, you write to the register and then you change the value before you get a chance to actually do anything with it. But I don't believe that's possible. But maybe I'm wrong. Because see, this is the update we get. So you can imagine for the write instruction, if it takes, I don't know, 5 cycles, we'll immediately call update with those 5 cycles here. Because we'll basically do that per instruction. And then in here, this is where, basically this is the code that relates to rendering. And then for each one of those cycles, we update our timers, our shift register. What did I write here? Check some flag. This might actually be important, because we are talking about the blanking. So blank, that is something that would make it so that we don't draw. You can either play with blanking, you can play with brightness. Those are 2 ways we can change drawing. Yeah. It's possible that it's blanking, and because I have this to do here and I don't remember what it meant. Check some flag on the shift register to know whether it's active. And then I am checking something on the shift register. For now, always return true, as it seems the shift register isn't disabled by games on Vectrex. Also, I'm not sure exactly how to control the enabled state on the shift register. I believe it may be controlled by bit 4 of the VIA's auxiliary control register. Okay, so there's the clue. I have some code here where I'm not ostensibly doing the right thing. Schematic time. Maybe not just yet. And I'm not sure this actually shows up in the schematic. This is like some details on how the shift register works. I said bit 4. I believe it may be controlled by bit 4 of the VIA's auxiliary control register. Let me see what that is. I said bit 4, and yet that's part of the shift register mode mask. Shift register mode. Yeah, so there are apparently different ways that the shift register can output bits, and I only support one, but I actually have an assertion. So if it was related to the shift register mode, I would have hit this assertion. It would have meant that the game would have asked to be in a different mode. So hopefully that's not what it is. But then again, it could be unrelated to this. So anyway, there's a clue there. So we can kind of look for that. Okay, so port A is D001. So let's see if my debugger can help us here. So let's do this. So there's the, starting from the face, it's 1, 2, so face is 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So was it this one we were looking at? 26, 27. I think it was that one. I wonder if there's a way for us to know that we're at this bit. Actually, there probably is a way. I have an idea. I'm going to open another trace of those lines. Oh, that's curious. F35.9 here. F35B. So we actually are falling through. Let me see. Let me go to reset pen here. Oh, okay. So maybe reset 0 ref was called instead of reset pen. Is that always the case? Yeah. Okay, it's reset 0 ref. Is that? Okay, so actually instead of F35.9, I should probably be putting my breakpoint on F35.4. Let me see. Show my breakpoints. What was it again? Disable 0 and break instead on F35.4. Okay, so it's going to be basically this one here. Okay. So 725 here. This is what I wanted to see. No, actually not this one, because there's a return. 728 is the place where we go here. 725. Like what I assume is that basically there's some code that's iterating over a bunch of vectors to draw. And so we're going to see some kind of pattern there. And just open up Beyond Compare. We're going to figure this out. Okay, so reset 0 ref. Is there like a expand selection, shrink selection, switch to control click for multi-cursor? Like I want to start selecting from here until the next reset 0 ref call. I don't know if I can do that in this editor. It doesn't look like it. All right. We will use our eyes like this. So this is one call, or one iteration anyway. Did I mess that up? What? Oh, yeah. Wow, this one's way longer than the previous one. Fascinating. But actually, that's not the one I wanted to see. I wanted to see this one. Because that's a short one too. Okay, let's do that. Swap. Okay, so it looks like the main difference is in the U register. So it's got basically a different value. Is there anything else? Yeah, it looks like that's the main difference. So it's going through this data to print the next bit. But then this part here is quite different. This is this long segment, which relates to the line segment. Let's see how that one compares. We swap this here. Okay, so it's actually the same for a good bit. Oh, did I like copy this wrong? Oh, yeah. Okay. Zero 5C0. So maybe that's our difference. Go break. Disable 1. Yeah. Yeah, okay. So the breakpoint I set does mark the beginning of rendering this line here. And then by the time it gets to rendering, so this routine is for rendering the long line. You can see it. See it rendered the long line here. So it's like top line, middle line, bottom line. And the other ones in between is just because by the time we hit the next breakpoint, now it's about to render the top line, and in between, in the interim, it's done this. Now it's going to render the top line, and in the interim, it's rendered these, the key, the ladder, spike, and now it's about to render this line here. Okay. So that's good. Next, we were saying we would look at the way it writes to D001. So once we've hit that breakpoint, so actually let me make a note of this before I forget, because it is so easy to forget. Start a routine to draw top, bottom of platform segment. It's not both, it's not top and bottom. It seems to be only one of them. It seems to be the top segment in this case. So now what we want to do is we want to set a write watch point on D001. Let's see how this looks. There's a segment. So 1, 2, and then this long gap. Okay, so let me disable this one. Get to here, enable one. Let's go again. It's very difficult because I don't know exactly what it's supposed to look like, right? We got 2 line segments and then a long one. Yeah, that's a good guess, Pyro. That would make sense, right? That the second one should not have been drawn. So if we focus on the one at the bottom, I think we got that same pattern, short, short, long. And assuming the second one should not have been drawn, maybe we can focus in on that. Five, and then C, 0, C. So there's one segment. And so then this next bit, and then the next one. And then the next bit. So let's try and hone in on that part of the trace. So actually we already have that part of the trace. So we can just look for the rights to D001 and see if we can figure this out. So we were at 06E8 to 0709. E8. Begin drawing invisible line to 0709. And let's compare that to the segment before it. So let me see here. Tuck, 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 tuck. So I think it was 07. Oh, 0709 again. So 06E8. Okay. It's all right. No, I think I've got this wrong. It's more like this. Oops. Okay, so let's see. That's not right. Because I have 4 bits like this. 06 E8. Okay, you know what? I'm gonna make a new trace. Because I know that if we work backwards from where we are pretty much where we want to be here. actually overwrote this. No? Okay. Okay, that's fine. And for line segment 1, we're going to look for this one here. Okay, finally. Now we can try to see if we can understand what's going on. And I think I can delete all this above just to simplify this file for me. So this is what line segment 1 looks like. And this will be what line segment 2 looks like. Quite different. I wonder if there's a place where it becomes similar. 7-Eleven. Very different code segments. Okay, so now we're starting to line up a little bit. but certainly the second one is different from the first. And I'm curious to compare the first and the third because both of them draw line segments ostensibly. So let's see if they look similar. This would be the first. And then line segment 3 is here. And I mean, they both start at the same address, so definitely there's a similarity there. But a lot more code here. There's also some music code in here. Okay, so let's see if we can focus on the only port A stuff is at the bottom here. That's interesting. Yeah, my feeling is that this has to do with the shift register. I see here that we're writing to the shift register. Here we're writing FF into the shift register. That would mean all ones. FF here for line segment 3. This is line segment 1, line segment 3 do the same thing. But what's going on for line segment 2? And then here we write 0 to stop it. So what happened in between? It didn't want to use a shift register because it would have wanted to disable drawing, right? It's possible that part of what we're looking for is here. Let me see, via control. So via control is what again? Is that the auxiliary control? Via control register, it's not the auxiliary, it's the one afterwards. It's the one we call peripheral control. Okay, so there's CA2 which drives 0 and CB2 which drives the blank. So is it trying to disable or enable the blank? Let me see. We're in the wrong trace now. Oh no, we're in the right place. We're trying to write CE here. And just to see, is there other via controls? CC, CE. One 110 is low. 5670. 567 110. But in both cases we were writing C, right? The only difference was CE. So 110 means blank is low, and I think blank low it means 110 means it's enabled, and blank enabled means we don't want to draw. And apparently that's only if the shift register is not enabled. Aha! But we always have a shift register enabled. Let me try a little something. I have some code here that would basically never set the blank enabled. Okay, I'm gonna have to disable my breakpoints. Darn it. Oh, and there's another one here. Okay, so there's still hope. I mean, what I'm doing right now is not the right fix. I just want to see if maybe this will fix it, you know? But probably what I need to do is figure out the logic for enabling, disabling the shift register. And then 111 high, so 0 high. Huh. So what does 0 high mean? I think it means it's disabled. Is 0 enabled? It's enabled when it's low, right? Yeah. Just like for blank. We got 110 and then 111. So 110 means this is enabled. 111 means 0 is disabled. Right, so we don't want to zero the beam, but we want to stop drawing. So that's what that means. Now, the way I had it, blank would actually never be set correctly. Set blank enabled. Shift, and then we read CB2 active here. Oh, that's totally different. Yeah, I need to do this correctly. Oh, I see. If the shift register is not enabled, we read it from here. If the shift register is enabled, we read it from CB2 active. Okay. Shift register CB2 line drives the blank, except if the shift register isn't enabled, I suppose. Okay. And then later we write CC here, which I guess is basically doing 110, 110, which would mean enable blank and enable zeroing. So this means we want to go back to 0. But it looks like I'm missing the other set of the via control because I guess I deleted too much. Let me go back to maybe a bigger trace. CE. Am I reading this right? It really is blank enabled, right? 110. Oh, hey, thanks for the host, Musin. Musin. I don't know how to say your name, but I appreciate it. So, okay, what we can do, I mean, like everything is pointing to the fact that this has to do with, well, okay, so there's a bit of, one thing that's confusing me is that it looks like we are here enabling blank to draw line segment 2, but what is it that stops the blank from occurring again? Let me take a look at that again. Yeah, so my guess is that checking if the shift register is enabled is kind of important here, because if it's enabled, then we use the CB2 line on the shift register. The CB2 line here, let me look at that, how that's set. Yeah, that has to do with while the shift register is shifting, we do blank, we control blank based on that state. And I noticed that the shift register gets set to 0, and I wonder if I should be using that to know whether the shift register is enabled or not. I'm going to try something. Okay, well, Spike's eyes are wrong, and it's not actually solving this problem. But let me see something. Let's look at the breakpoints again. So I did not get a disable. How's that possible? Oh, and then I just got one now. set blank enabled. Just turn to false. So we disabled it. Now the shift register is enabled, ostensibly. Which would mean the shift register got a value. Oh, blank is still false. So, all right, we want to see if blank would become true. That's true. Now it's true. So we don't see anything, and then all of a sudden the shift register got a value and it became enabled. So I think what we're supposed to understand is that it uses a shift register to draw the line segment, and then I think when the shift register runs out of values, it should be blank for the next write. It's a bit hard to do on one screen, I'll be honest. Let me disable one. Okay, so we are now blank. Now we are supposed to draw because we're not blank anymore. And we drew that line. And see now, I think the next segment, we should have been blank. Here. Okay, let me try this again. We're getting closer. So I wanted to do this. So we're now blanking. Yep. false. Yes, to draw that line. Okay. For the last 9th shift cycle, we output the same bit that was output for the 8th, which is now in bit position 0. We also don't shift. Is that correct? That doesn't seem correct. That's probably my bug. I'm holding on to a bit in the shift register, and it seems to me like Spike is expecting the shift register to run out. This logic always seemed very odd to me. Hence the question, is that correct here? Let me try and shift out and see what happens. I'm going to put this back to return true, because I don't think that will change anything. Disable these. Oh, so close. Enable 0. Okay, so here's a change to blank. Blank is now false, so it means we're going to be drawing. All right, Pyro. Hopefully I'll figure this out tonight. Thanks, man. Appreciate it. I'm really close. I'm feeling I'm really close. Actually. Thanks, man. Okay, you know what? I'm gonna try something here. Shift register. Disable optimizations. Put a condition when this is not 0. So here we are. M value B. So yeah, so we'll often get into a place where, is that possible? How does this work? Shift cycles left 18, update 2 cycles. For each cycle, if we still have some, for every even or odd, ORed with the bit. Yeah, there's something weird about the shift register. So we have a value, okay. Do we ever get, okay, value of 120. Looks like that. And then we only shift on when it's odd. It's not the last. And then we do this. We shift left. Is that right? This is completely wrong. I'm going to have to read up again on the shift register. I think everything seems to be pointing to that. And hopefully I'm right, but... Okay, that's not much better. Interesting, though. Why do I say it's now in bit position 0? Because we would have ORed it? Okay, because it's, oh, it's a shift register that cycles. Oh, I see. That's right. Okay, that's right. Now I remember. Okay, so, all right. Yeah. CB2 is active when the bit is 0. That's right. And then CB2 active is used to drive the blank. Blank is enabled when it's 0. Okay, yeah, that makes sense. It gets shifted that way. Now the bit is set, and now the bit's going to rotate. We're going to get 1, 1 with a 1 in the top. Yeah, so now I'm starting to think this is actually not incorrect. But there is this thing here that's bothering me. The inability to set the blank through the peripheral control. And this idea of the shift register, whether it's enabled or not. Because it certainly looked like it was trying to do that in the code. And this would basically not do anything for us right now. So if we didn't rotate the bits, what would happen again? That. Okay, so definitely we want to be rotating our bits in there. That confirms it. Okay, I'm going to stop here, And I'm gonna look again. I'm going to write down what we'll do. Let's go to do here. What do we learned here? So fix spike. I think the problem is related to the fact that it's not possible in my emulator to set blank via the perif control register. Basically, shift register always turns true, so this cannot set blank. The code for spike does try to set this value to blank. Look into how shift register enabled state is supposed to work. Keep in mind that the shift register rotates its value, so it's not a matter of not rotating anymore. We tried using the interrupt flag, which is when there are no more shift cycles left. That didn't work either. Although reading would reset that. Oh, and that would also reset the shift cycles, yeah. Bonjour. How's it going, Bama? Or what was it again? It was sorry, I'm forgetting your name. You said it last time. Was it Barim or something? Brahim. Okay, Brahim. Am I saying it right? Is it like Bram or something? I don't know. Not particularly good at pronouncing names, I suppose. You're French. From France? Bahraim? Okay then. Yeah, it didn't work to return here the interrupt flag. Oh, okay. So it's an Algerian name. Want to see what this does again. Because we saw also that the shift register gets set to 0, right? here. See, it gets set to 0. But that doesn't mean it's disabled, right? It just means we're going to get 0 values out of it. I'm actually about to sign off. Brahim. You read might get the code for Vectrexy? Yeah, so you're reading more about that. That's cool. How often do I push? Well, you can see that, right? If you're looking at my commits, you can just look at the dates. You'll see that I push, fairly often. All right, I'm gonna stop here, guys, because I'm getting tired and I need to step away from this for a little bit. But yeah, I think we're getting there. We're getting closer and closer. Yeah, so Brian, if you want to know, just take a look at you go on here and you just look at my commits, you'll see that, you know, 2 hours ago, 2 days ago, 5 days ago, 8 days ago, these are all the commits that went in. So that should give you an idea of the frequency. You can see the dates here. But yeah, because I know I'm streaming this project, it's pretty active, right? I end up, you know, twice a week I'm streaming, so I'm usually committing for those nights, and in between streams I'll often work on it here and there. So yeah, it's a pretty active project. All right, guys, so I'm gonna take off, and I should be back as usual next Tuesday. So hopefully, if you wanna, you know, follow along, we'll keep hammering out this spike bug. So thanks again, and see you next time.